Hello, everyone. I'm Aditya. I work at InMobi. I've been here at the data platform team for like over 5 years now. And today I'm going to talk about a custom autoscaler that we built for leveraging Cosmos DB efficiently. So without further ado, let's jump right into it. So just a high level architecture of how things work at how we are using this. So basically there's Cosmos in the center, which you can see, and then there is a client which is reading it throughout the day. This is like a 24-hour thing, which is like there's continuous write, the continuous read. The pattern for reads keeps varying throughout the day, and on the left you can see that there are multiple batch jobs. So it is these batch jobs that are responsible for writing to Cosmos DB, and the nature of these batch jobs is such that they run just for a few hours in a day, or like with some particular frequency. Say for example, batch job 1 may run like at an hourly level, whereas batch job 2 might run once a week, and then there might be another batch job which might run once a day. So the frequency for that can vary, and the throughput at which they are going to hit Cosmos, so that varies. So the load on Cosmos is varying throughout the day. So and at the bottom you see is the autoscaler. So this is the thing that we are going to talk about in this session. So first of all, before we get into the autoscaler, let's look at what is the pricing model of Cosmos DB. So pricing in Cosmos is based on something called request units. So a request unit is basically a transaction, that a unit of transaction. So for example, if we do a read from Cosmos DB, it is going to cost some RUs. If we do writes, it will cost a few more RUs than that. And the number of RUs that are spent in doing any kind of operation in Cosmos is dependent on what is the type of operation, what is the amount of data which we are loading. So that is, and all the costing which happens in Cosmos DB is based on these RUs only. So another important thing to note is that we are charged based on how much RUs we have provisioned, and not basically on what we are actually using. So that is what is the RU. And on top of that, the cost also depends on the maximum RUs that we provision for an hour. So let's say that we have provisioned 500 KRUs for, let's say, 5 minutes, and for rest of the hour we have just provisioned 100 KRUs. So we would still end up paying 500 KRUs for that particular hour. So, and also in a multi-region environment where there are like multiple read and write regions, so the cost is the same. The cost of each region will be added up, and the final cost is basically n times the number of the cost for the maximum RU that you have provisioned. So let's have a look at the traffic pattern that we have. So so as you can see, so there are like three colors here, the blue, yellow, and the green at the top in the image. So here each of these represents a different region. So the pattern that we have is we have a single write region, which is the green one, and the other two are just simply read regions. So read is happening on all the three regions, whereas the write is happening in only one region. And so there's a continuous variation in the reads, as you can see here. So there's a gradual pattern based on the time of the day. So the amount of traffic in these areas is like varying. And you would also be seeing that what are these peaks. So these peaks are basically the bursts and writes. So the batch jobs which I was showing you at the back, these are basically the result of that of the bursts which are coming because of the batch job. And also the pattern, as you can see, is clearly varying with every region based on the time that is there in that particular region. And typically we have seen that the load on our Cosmos DB, it can vary. The required RUs can vary right from something like 100K at a time to even 2 million. So there could be like multiple jobs that could be running, and there could also be like very high QPS on the read side. Therefore this is like the traffic pattern. So now let's move forward. So now, given the fact that there is so much variation in the traffic that we have, so now we have got a few options in like for scaling and for setting the RUs. So these options are basically fixed scaling. Fixed scaling is basically just set a constant number of RUs and forget about it. Then we have the Azure Autoscaler, and then we have a custom autoscaler that is an in-house solution. So the thing with this uh, or Azure Autoscaler is that the time when we actually started using Cosmos, which was way back in 2018. So that time this was not even available as an offering. So therefore we had no choice but to build a custom autoscaler. So now we are actually going to see how the custom autoscaler is functioning. Has it stood the test of time? Should we now switch to an Azure to the Azure autoscaler, or is the custom autoscaler still, does it have some niche advantages? So let's move forward. So let's talk about fixed scaling for first. So fixed scaling is very simple. Just provision a constant amount of RUs based on the usage that you have and forget about it. So the good thing about it, this is that there's no maintenance required. So just one time you have to think that, okay, how much RUs do I want? And then based on that, you can just move ahead with it. But actually, if you see now, there is still an issue. So do you actually set the RUs where based on your maximum usage? Because like based on the traffic pattern that I just showed you earlier, so if you will actually set the RUs as per the maximum value that we have, so that will actually result in a lot of wastage, and a lot of wastage means a lot of cost also. And if you set it something like, the other option is like set it to the average value, that how much RUs are getting used. So in that case, the issue is that there will be throttling in like a significant number of the cases. So basically, wherever your writes are happening, at that time you will get throttled, because that is the time when we are getting the peaks in the RU usage. So this fixed scaling, either it's very costly or it's just not feasible, because it does not serve the business use case. So now, since that is not an option, so now we'll look at what are the offerings that Azure is providing now. So Cosmos DB in itself is providing an autoscaler. So now coming to the benefits of that, so it's very easy to enable. So just go to the portal, click the button, and that's it. It's just a one-click solution. There is no maintenance required from the client side, and we can even define what are the range of in which we want to scale the RU. So you can specify, let's say the maximum scale is, let's say, 2 million. So you just specify that the maximum scale is 2 million, and in that case, just by default, it takes a range of like 10% of max to the max. So that means the autoscaler will always keep the RUs between 200k RUs and 2 million RUs. So basically, as you can see on the right, so the RUs which are set by the Azure autoscaler, it is a function of the RU usage and the maximum throughput which you set. So it's as simple as that. However, there are also a few problems with it. So first of all is the pricing itself. So just for using the Azure Autoscaler, if you're using it in a single region, so then the price of the RU itself is 50% costly. So let's say that you want to use say 300k RUs, and sometimes the traffic even goes up to 350k RUs hypothetically. So in that case, it may still be better for you to use a fixed scaling solution where you just set it to 350k at max, because what cost most autoscaler will be charging you will be 1.5x of that. So you will effectively be paying for 450k RUs. So this pricing, it is a very big issue actually. Then another issue with this Azure Autoscaler is that it is not good at handling bursts. So we have actually seen in production that with this Azure Autoscaler, so first of all, when there is a burst in traffic, it will take some time to react, and there'll be some throttling at the beginning. Then at the end of the burst, we have also seen that it will take some time to scale down. So we end up paying extra, and basically both the situations are not good. Even further, now take a look at the image which is there. So the pattern in which the RUs are being provisioned is also not same as the usage pattern. So the usage pattern is at the bottom, whereas the provisioning pattern by the with the autoscaler is at the top. So as you can see towards the right end of the image, so the even though the usage is very less, even then the autoscaler is actually provisioning at the maximum throughput, which in this case we had set to 1.4 million, and it is actually provisioning at 1.4 million only, even though it is not needed. So this is like a serious issue with the Azure Autoscaler. So now let's also take a look at the custom autoscaler which InMobi has built. So the first thing is basically what is the custom autoscaler? It is a scheduled job which runs with a granular frequency. So we can customize what frequency we want to run it at. Then we also have so basically what this job does is it scales the Cosmos DB RUs up and down based on the pattern of consumption. So it checks all the metrics that are there, and based on that, it will basically scale it up and down. And the amount of change that it should do is totally configurable. So let's see how it works. So the first thing is whenever the job is triggered, so this is scheduled, it keeps running on a scheduled frequency which we can set. Then based on that, it will get the metrics for all the regions. So these metrics include the provisioned RUs, usage of the RUs, and the amount of throttling that we are seeing in all the regions for the last, let's say, 5 minutes, 10 minutes, or whatever time you want. You can configure that time. Based on that time, based on these metrics, then we estimate what is the scale. So whether we should upscale the RUs, whether we should downscale the RUs. So based on that, or whether we should leave it as it is. So then that scaling is estimated, and then based on the maximum and minimum throughput which we have set, we can also put a like a hard limit that even if the scaler is estimating to go beyond the any of the limits, we will just scale it at the limit. We will not provision more than the max limit or provision less than the minimum limit. And then we also check the scaling eligibility. So what the scaling eligibility is, that since as I mentioned, we have to pay for the highest number of RUs which we have provisioned within an hour. Therefore, we only downscale at the end of the hour, because there is no benefit in downscaling in the middle of the hour. So if we are trying to downscale and it is not at the end of the hour, then definitely we will not downscale it. So, and then based on all these calculations, if the job says that okay, we have to scale, so then basically it will make an API call to Cosmos DB, and it will be setting the resources as required. So let's look at the benefits of this approach, of this autoscaler. So first of all, it is able to handle bursts in traffic. So how does that happen? So as you can see, these peaks have like different heights. So each of these peaks basically corresponds to a different batch job, which is writing at a different QPS. So here, what this batch job will do is that whenever the batch job is about to run, so since the right part is in our control, so then we can definitely tell the Cosmos in advance that okay, this is the amount of RU that I'm going to use. So for example, in this like image, you can see that from 100K the usage has gone to 300K. So in this case, the batch job would already know that the QPS at which I'm going to hit the Cosmos DB and the operations which I'm going to do, that will use 200K. So in the config of the job, so the job itself will tell this autoscaler that okay, this is the amount of extra RUs that I need, and based on that, the limits will be accordingly pushed, and without any throttling, we will be able to get an increased RU usage exactly when we want, and as soon as the job is done, we will downscale the RUs. So, and similarly, a different job can operate at a different scale. So like for example, this job is operating at 100K RU only. So this is how we're able to handle the bursts in the right traffic. Now, the other pros are basically the scaling logic. So we have total control over the scaling logic. So for example, we are able to control what rate should be upscaled. So unlike the Cosmos, where was simply a function of the throughput and the RU usage, here we can actually control that okay, if there is a bit of throttling, then upscale by let's say 20%. If there is like extra usage, downscale by let's say 30%. So these are independent rates that we can set based on the pattern of our traffic and based on a business use case. Then also we can set a buffer. So let's say we want to actually always keep a buffer of say 5% over the traffic, so that there is no throttling or there's minimum throttling. So for that case, we have this buffer percentage, and like since multiple teams at InMobi are using this solution, so some teams have a use case where it is a very strict, like there has to be no throttling, so they keep a buffer of let's say 25%. Whereas let's say for my team, we are okay to tolerate some kind of throttling. So the buffer we have kept is around 5%. So this is totally configurable. So another thing that this solution provides us is having a flexible upper and lower limit. So you remember that I gave the example of being fixed, being bound with the Azure Autoscaler, where if we want 2 million RUs, then we also have to have a minimum of 200K RUs. So with a custom autoscaler, that problem is not there. So the benefit of this is because these are both decoupled configs, so we can simply set the lower limit as say 50K or 100K, and even then we can set the upper limit as 2 million. In addition to that, there can also be cases where, let's say there is some outage on our side. So let's say that we are using a read cache, and that on the read side, and that cache basically, since that is self-managed, let's say it is not able to serve the traffic, and all the requests start coming to Cosmos. So in that case, the traffic on Cosmos will increase massively, and it could cause throttling. And it's not really feasible for us to expect someone to manually go and increase the RUs. So the autoscaler also takes that into account, and based on the traffic, if the throttling is beyond a threshold, so it will suddenly increase the RUs by a fixed amount. So as you can see in this graph, so instead of increasing by a simple 20%, here it is directly increasing the number of RUs by 250k. So from 200k, it's gone to 450k. And similarly, if the throttling is very high, it can even do that in 2 jumps. It can increase by 500k. So this is the benefit that we are seeing. So this two-phase scaling is not available with the Azure Autoscaler. So now if we really look at the in-house autoscaler, so it is a function of the RU usage that we have as the input. What is the maximum and minimum throughput that we have set? What is the amount of throttling that we are seeing, and the rates of the upscale, downscale, and the buffer. So there's a lot more control that we have with the custom autoscaler. Now there are even more benefits. So since in Azure, we are using a manual autoscale mode, even though this job is running on top of it. But as far as Azure is concerned, we are using manual autoscale. And because of that, the pricing is much cheaper. So we don't have to pay that 50% extra surcharge, which Azure Autoscaler is expecting from us. Then another thing that we can do is the downscaling is always done at the end of the hour, as I told earlier. So basically that, so let's say that this is the time when the job is getting over. And so basically, so this time is in IST. So in only in the last hour, so just before 9:30 only, in this last, let's say we have said that the downscale will happen in the last 30 minutes. So only after this 9 p.m. mark has passed, only after that this downscale is happening. So basically for this extra amount of time, we are not wasting the RUs by going down to the minimum required right away. So we are able to use extra RUs for that time. However, this approach does have some disadvantages also. So as you may have realized, so one is basically we have to maintain the job, we have to deploy it, and we have to take care that the job is running continuously. So that is one. Another thing is basically all these configs that we are setting, even though we have got a lot of control, however, all these configs that we are setting, it is very important that these configs are set correctly. And for this, it does require a bit of experimentation. So it does take some time to set the right value of the configs. So now that we've looked at all the solutions, so what is the future scope for this autoscaler, for the custom autoscaler that we have built? So one is basically we are operating so far in a reactive way. So if let's say some throttling will happen, based on that we will increase the RUs, or if the usage is less, we'll decrease the RUs. We are also actually doing it preemptively only in cases where let's say some bad job is running. However, the whole thing can be made predictive with using ML. So that is in one of the future scopes, that we can analyze the pattern of traffic, and then based on that we can apply ML to proactively provision the RUs instead of doing it reactively. Then another thing that we want, I'm sure by now many people in the audience want to actually try their hands on with this library. So as of now, it is a proprietary library. We have not open sourced it, but we are actually considering like open sourcing it. So soon you may be able to hear something about this. So overall, what's the conclusion? So this autoscaler has been actually a great saving for us. So as compared to fixed scaling, so we've computed that it's helping us save more than 80% of our cost. And as compared to the Azure provided autoscaler, we are saving more than 60% of the cost. And because of this, now the solution is being used by multiple teams. There are at least 7 to 8 different teams that are using this solution. Like whoever is basically using Cosmos in the company, they are all using this solution. And overall, this is giving us a saving of more than $5 million a year. So by building this autoscaler, it has actually enabled us to leverage Cosmos DB in a much more efficient way. And we are able to operate at QPS like more than 1.5 million QPS regularly. And sometimes we even go as high as 2 million QPS. And we are able to do it in a very cost effective manner. So yeah, I think that's all from my side. Yeah, thank you, everyone. So if anyone wants to contact me, so my details are here. That's all. Thank you.